Hi students, in the first video we discussed about the Euclid division lemma. Now the most important concept in the 10th class first chapter of mathematics virtual, that is real numbers, that is how to calculate the HCF by using Euclid division lemma. So you know that what is HCF? HCF is highest common factor. Another name of HCF is greatest common divisor. Okay, so here, so we call it HCF or we call it as GCD. So how to calculate this HCF by using Euclid division lemma? So before going to the topic, first of all, I tell you what is HCF. You know, according to the definition, according to this full form, the highest common factor. For example, I'm taking two numbers, 10 and 18. Yes. So you know the factor. Factor means the number which divides the given number exactly is called factor of that number. For example, we take the factors of 10. We can know that 1 is factor of 10, and you see 1 tens are 10, 2 5s are 10, yes, and we don't get still any other 3 4 5 5 2s are again with recipe. So 1 2 5 and 10 are the factors of this 10. And if you take that 18 factors, for example, now you take 18, so 1 into 18 is 18, 2 9s are 18, 3 6 are 18, and still 4 table we don't get, 5 table we don't get, 6 table 6 3 0, so that is repeated, so we can stop it. 1 2 3 6 9 18. So in this, if you observe the common factors, 1 is common factor, 2 is common factor, still any other common factor, so there is no other common factor. So highest common factor is 10, HCF of 10 and 18, that is 2. Highest common factor is 2. Okay, so you know that for any number, 1 is common factor, 1 is a factor. Okay, so lowest common factor is always 1 only. But if you take the common factor highest, that is 2. Okay, so here if you take some cases we don't get any common factors. For example, 10 and 9. So if you take the 10, already I have written factors 1 2 5 and 10. And if you take for 9, factors 1 3 and 9. So there are no common factors except 1. So in this case we can write the HCF of 10 and 9 is 1. So when the HCF is 1 for any two numbers, they are called co-primes. We call them as co-primes. Okay, so here in any case, if you want to find HCF of two co-primes, just you have write just 1. Okay, now the same HCF we already learned in 6th class by using division method. For example, 10 and 18 is there. In the division method, how do we do? That is, we take the bigger number and we divide with the smaller number. 10 ones are 10. We get remainder 8. Again, this divisor you write here, 8 1 is 8, and the remainder is 2. Okay, again this divisor will write here and divide with 2. 2 2s are 4, and the 2 4s are 8. So the remainder is 0 here. So HCF is 2. So we got here. So the same thing, if you write by using Euclid division algorithm, then there is a process of calculating HCF. Now let us go to the, let's see in the textbook. Now see here, find HCF of the following by using Euclid division algorithm. So we see this example. So here, do these problems. The first one is 50 and 70. Okay, so 50 and 70 I'm calculating here. For 50 and 70, I calculate HCF by using Euclid division algorithm. First one. So let's see here. So I'm taking here question 50 and 70. I'm calculating HCF. First of all, Here we are using Euclid division algorithm. So that's why you should write, you have to assume the bigger number as A and the smaller number as B. Okay. So bigger number is 70 and smaller number is 50. So here by using EDL means Euclid division lemma. So that's we know that A equal to BQ plus R. Okay, and if the condition is 0 less than or less than B. Okay, and the remainder is exists between 0 and B. So here I'm taking 70. I'm writing in the form of the simple equation 70 equal to 50 into 1. 51 is the 50. So how much remaining? 20. To get 70, we should add 20. So 50 into 1 plus 20. Again, in the second case, this A is 50 and B becomes 20. Again, we have to take 50 equal to 20 into 2 plus 10. 22 is a 40. So the 40 for 40, we should add 10, okay, to get 50. And if we take another, again, see here also we don't get 0. And if we, now we have to take A equal to 20 and B equal to 10. So here 20 equal to 10 into 2 plus 0. So here we got 10 as, here we got the remainder 0. So that's why 10 is called HCF. That is 10. Okay, means if you know perfectly, if you are able to do perfectly, you can do in this process, or we can use the same thing we can use by using, we can do by using division also. Yes, means we have to do here division and then you are right here. For example, if we take here, I'll explain the same problem in this way. Suppose if you have confusion in doing this, you can write that in this model also. Taking the first question, that's 50 and 70. It's only one thing you have to do. You have to take the bigger number as dividend and smaller number as divisor. 50 ones are 50, got remainder 20. Now here, by using EDL, Euclid division lemma, A equal to PQ plus R and 0 less than or less than B. Now you have to assume that A equal to 50, 70, bigger number as 70 and smaller number as 50. So we get 70 equal to 50 into 1, 50 into 1 plus the remainder 20. Okay, again what you do here, this 20 is the dividend divisor and 50 is the dividend. So now 22s are 40. Again for this also you have to write the statement. So now here we have to take A equal to 50, B equal to 20. So 50 equal to divisor equal to dividend into quotient plus remainder. Again, still we don't get, we did not get the remainder 0. Again, we take here 20, 20 to the 20. So remainder is 0. Now, we are taking 20 as a dividend. That A equal to 20, B equal to 10. And so now we can write 20 equal to 10 into 2 divisor into quotient plus remainder 0. So we got remainder 0 here. So the number which divides that number exactly is 10 by both numbers. So 10 is common factor for 50 and 70, and that is the highest common factor. So HCF of 50 comma 70, that is 10. Okay. So here no need writing for every step A equal 20, B equal 10. Just you can write in this way also. So here, first of all, we take the 50 and 70, and rest we have to write the statement by using Euclid division algorithm. A equal BQ plus R, and condition you should write. Now we should write the first one. First step, you write here 70 equal to 50 into 1 plus 20, and 50 equal to 20 into 2 plus 10, again 20 equal to 10 into 2 plus remainder 0. So directly you can write HCF as HCF is 10. So the more simple way to write. Okay, so you can, if you want to write with explanation, yes, you can write in this way, or you can do in this shorter way also. Okay, let us do the second problem. 96 and 72. So in this case also, and second one taking 96 and 72. First, what you have to write? We have to write the Euclid division algorithm statement, not so in the form of equation. So by using Euclid division lemma, EDL A equal to PQ plus R, condition 0 less than or less than B. Now we can write it as 72 equal to, so here we have to take the bigger number as 96. So I'm taking the division here, 72 1 z 72, and here we get remainder 4, 6 minus 2 4, and 9 minus 7 is 2, so remainder is 24. Again, so here to write the statement, let A equal, the bigger number is 96, the smaller number is 72. So according to this one, so dividend equal to divisor into quotient plus remainder. Now we did not get the remainder 0. Again, this one, the previous divisor becomes as dividend. Now we know that 24 3s are 72. So here again, what to write? Let here the divisor becomes dividend, and the remainder becomes divisor. So here what you got? 72 equal to 24 into 3 plus 0 remainder. So there's only one thing here. We have this one, we should be able to write in the form of a linear equation. Okay, so when we got the remainder 0, that's why 24 is HCF. HCF of 96 and 72 is 24. Okay, so this is the process of doing. In some cases, if you have the large, now if you see this third one also can do easily, and the fourth one, this one also can do easily, and okay, I will explain this fourth one. You can try the third one. Taking here this fourth question. So here by using ETL, Euclid division lemma, A equal to BQ plus R, 0 less than or less than B. Now we start the problem. So we have to take the bigger number as A. Let A equal to 2015 and B equal to 1860. So A is, you know that A is the dividend and B is the divisor. So this is 1800 and this is 2000. So you know that 1800 to the 3600, that is more, that's very big gap. So we have to take only once. 1860, 1860 into 1, 1860, and 5, here 5, and here 1, here we got to carry 11 minus 6, 5, and we have here from here 9 minus 8, 1, and 1 minus 0. So here, if you write the statement, 2015 equal to 1860 into 1 plus the remainder is 155. So again, what to take? Let A equal to 1860 and B equal to 155. This becomes A, this becomes B. Okay, so we have to continue until we get the remainder 0. Okay, So here 1860, I am taking here 155 ones are 155. Now I did not divide this total number. That's why we have to take one more step also in the division. 6 minus 5 is 1, 8 minus 5 is 3. One more way also. Some students will take again directly here 155 and they will try to do, so they don't get and they leave the problem. That's why you should not do that mistake. You should see the remainder. We observe the remainder. Now this remainder is not less than this divisor. So more division is possible. So you should continue. 155 ones are 155, 155 twos are 310. So here on we got the exactly the remainder 0. So means, so here 1860. So you got here 1860 equal to 1860 equal to 155 into 12 plus remainder 0. So as 155 is dividing exactly with remainder 0, so HCF of 2015 and 1860 is how much? That is 155. So students, in any case, you have to write that answer and you try to underline that answer. Okay. So this is the calculating HCF by using Euclid division algorithm. Now we have the first bit in the exercise. And before that, here we have the think and discuss question also. That is, can you find HCF of 1.2 and 0.12 by using Euclid division algorithm? Actually, Euclid division algorithm is already stated for only positive integers. Yes. Okay. So here 1.2 and 0.12 are not positive integers. They are not integers. They are decimal numbers. So Euclid division algorithm, we can extend to calculate shape of this decimal also, but now here we're not finding that. Okay. So here we can write that Euclid division algorithm is depend on only positive integers. So that's why we cannot find, we can write. Okay. And here we have some remarks. I'm reading that. Yeah, those are most important in order to also see this. Euclid's algorithm division algorithm are so closely interlinked that people often call as division algorithm also. So Euclid algorithm or Euclid division algorithm. So I told you EDL, Euclid division lemma, or EDA, Euclid division algorithm. So those are closely interlinked and sometimes we call it as division algorithm also. And also, although the division algorithm is stated for only positive integers, it can be extended for all integers a and b where b not equal 0. Sure. Here we are not going to discuss about it. Okay. So here by using this model, we can solve the problems in exercise number 1. That is the first bit. Use Euclid algorithm to find the HCF of these all the numbers. Okay. So in this, I want to explain the second problem. This one, I'll explain here. One 96 and 382220. Okay. So I told you first of all what to write while starting. So by using Euclid division algorithm or Euclid division lemma, A equal to BQ plus R and the condition 0 less than or less than B. I told you to assume that bigger number as let A equal to 38220. The smaller number is 196. I'm doing here, doing the division here, taking the bigger number as dividend and smaller number as divisor. So here 196 twos are, we know that to 392. Okay. So here that is bigger than this 382. Okay, that's why we should take only once. Now the division is not completed still. Here we get one more. So why? Because here I did not take all the numbers. 12 minus 6 is 6. I drop it 2. And here 17 minus 9 is 8. Okay. And here we have 2. 2 minus 1 is 1. Okay. So 1862. That is almost nearer to 196 times or 1960. So we can take 196 nines. 9 6 are 54. 81 plus 5, 86. 9 1 is 9 plus 8, 17. So that is 1764 we got in 9 times. Again, still here one more is there to drop. Here we can take borrow. 12 minus 4 is 80, 8, and 15 minus 6 is 9. So here still we can do it. So here let us try with that 19 5 is a 95. That is almost equal to 950. So that is 196 5 is 980. So that is means in along. So with 196 only we got that answer. Okay, we got the remainder 0. That's why we can write the statement and we can write HCF as 196 as 196 is dividing it exactly with remainder 0. Okay, so 3822 equal to 196 into 195 plus the remainder 0. So we got the remainder 0 here. So HCF is 196. Okay. So this is the HCF, calculating HCF by using Euclid division algorithm. Okay. Thank you, students. And we discuss the remaining problems in the next video. Okay. So all the 4 problems I'll explain in the next video. Thank you.